All right, let's take a look at domain and range. So by definition, domain is the list of all possible x values of a function, and the range is the list of all possible y values of a function. So we'll start off with some two basic functions. Here we just have a list or a group of ordered pairs. So the domain would just be to list out all of the x values, and the range would be to list out all of the y values, right? And we could actually take this and represent a group of ordered pairs, and if we were to graph them, a group of ordered pairs would just look like individual points. So if you're given a graph with individual points, you can look at, you can write out the coordinates like I did, and then the domain is all of the x's, and the range is all of the y's. So we write them with this group notation, or this set notation with these little like fancy squiggly lines, because the only x values are the x values for these individual points. Same thing with range. Now we keep that same idea of domain as the x's, range as the y's, with more sophisticated functions where the function is more continuous, where there's an infinite number of points here. So what I like to do is think about domain and range is all the x values. So I'm looking left and right. Range is all the y values, so I'm thinking up and down. If we start with this guy, domain, when I see these arrows, that means this function is going to continue forever. It's going to continue forever going down and slowly going to the left. So if we were to expand this graph, expand this axis, make this way bigger, this graph would be going to the left forever, and same thing on the right forever. And notice if we were to put our pencil on the graph and trace over it, we never pick our pencil up. So that means every single x value from negative infinity, all in the middle here, and then to positive infinity is included on this graph. So the domain is negative to positive infinity, going left to right. Range is asking how far down and how high up does the graph go, how low to how high. Well, again, these arrows pointing down tell us we're going down to negative infinity. We're going to go down forever. But as we trace over, we see the highest this graph is going to go is to 9, right? If this was an elevator, it could go down forever, but the highest it can go is to a y value of 9. And we are touching 9, so we put these closed brackets around 9. Notice we always put parentheses by infinity. Okay, so if we take a look at another example, this is also a continuous function. When we trace over it, we never pick our pencil up. I see a down arrow, meaning we're going to go down and to the left forever. So notice we're going to go to the left forever. We're going to go down forever. But this time on the other side, the arrow's pointing up, which means this function's also going to go up and to the right forever. So as far as left to right, our domain, we're going to the left and to the right forever, so negative to positive infinity. Similarly, because the arrows are going in opposite direction and it's continuous in the middle, our range is also negative to positive infinity. That means every x value will be included on this graph and every y value. Okay, let's try another one, number 5. So this one, again, I see some arrows that say it's going to continue forever. So if we're thinking domain first, left to right, this graph is going to go to the left forever and continuous, never pick my pencil up, and it's going to go to the right forever. So negative to positive infinity. But this time the range, I see the arrows, actually both arrows are pointing down. So negative infinity as far as how low does this graph go. But then the highest this graph goes is up to positive 5. Notice the closed brackets. Number 6, so this is where we finally start getting a little bit trickier, because we start to see that this function does not go on forever in both directions, and we have this open circle where we would have to pick our pencil up as we approach it. So as far as the domain, how far left and how far right can we go? I always start my domain looking at the left, and I say, well, there's not an arrow, so our domain isn't going to negative infinity. The first place we start with our domain is at negative 6, right? That's the first spot in the x-axis that we see some blue. So I'm going to list negative 6. However, this point at negative 6 is an open circle, meaning we're going to get really, really close to negative 6, but never touch it. So the way we do that in our domain is we use an open parentheses. And then once we go from negative 6, we start to move to the right. We notice every point inside here, I'm not picking my pencil up at all, so every x value is included on the graph, and then I see this arrow, which means that as we move to the right, every x value to the right will be included, meaning we're going to go to positive infinity. So our graph starts at -6, doesn't include -6, but starts really close to there, and then goes on to positive infinity forever. As far as the range, how low and how high, I don't see any arrows pointing down or pointing up for that matter. So I have to just kind of look and see how low is this going. And I see that this graph is going as low as -5 and then as high up as +1. So our range, the graph, is stuck between -5 and +1, and we show that interval with our range, both of them with closed brackets, because both of these points are filled in and closed. So we do closed brackets from -5 to +1. As we continue, this is also similar. So if we look at domain, how far left, how far right, here we're starting at, let's see, -5, this is -8. So open parentheses at -8, and then we trace over. It's continuous. I'm never picking my pencil up, and then it goes to the right forever. So -8 to positive infinity. As far as how low and how high, I see I'm going as far down as -9, but because of this arrow, I'm going up forever. So our range is as low as -9 and then up forever. And then we finally have our step interval. So this is a unique one. There's different ways people approach these, but we're just going to go based on what we see. So as far left and right, how far left, how far right are we going? Well, the first point I see as I look to the left is a closed point at -10, so I put closed. And I start going and I see that there's an open circle. I have to pick my pencil up and I have to jump up here to where there's a closed circle. So this function is not continuous because I have to pick my pencil up. However, every x value, like at -6, where it starts to get where I have to pick my pencil up and move it, although there's an open circle here, there's a closed circle here. So -6 is included in the domain. And then I'm good until I get to -2 and I start to worry, but then I just jump up here and it's closed, so then I don't have to worry about it. And that happens with all of these steps, right? So actually every single x value between -10 and +10, notice it's an open circle, so we do open parentheses, all of those x values are included because we can drag our pencil around. We do have to jump, but it's closed, then we drag, and so every x value is included. Now that's different from the range. The range is how many y values or which y values are being graphed. I see that all of these points, this whole segment, all have the same y value of -9. When we jump up, we skip over all of these y values, so we can't include them. And the next points that we see is up here, and they have y values of -7. And then we jump up, these have y values of -5, -3, and -1. So we list those individually as a set like we did in the very beginning, okay? So this is how we find domain and range given a graph. But we're also going to have to find domain and range given functions. And so it's really important to make sure we know about some general characteristics of a couple functions. So we looked at their graphs yesterday. So I want to go back and now talk about their functions. So in green are the functions we're going to be we'll see that have no restrictions. So green means go. That means their domain is going to be negative to positive infinity, meaning that there is nothing that is not allowed to happen, right? There are no restrictions. That means any x value can be plugged into these functions. So any x value can be plugged into polynomial functions. Any x value can be plugged into an absolute value. And any x value we can take the cubed root of. For example, we can take the cubed root of a negative, right? The cubed root of a -1 is -1. The cubed root of -8 is -2. The cubed root of 0 is 0. The cubed root of +8 is 2. So we can take cubed root and really odd roots of negative, 0, and positive numbers. There's no restrictions. Same thing with absolute values. We can take the absolute value of a negative number, We can take the absolute value of 0. We can take the absolute value of a positive number. There's no number we can take the absolute value of, so we have no restrictions. And the same thing with polynomials. So if you're given a function and it's a polynomial, absolute value, or it has an odd index, then your domain is going to be negative to positive infinity. You don't have to worry about it. Green means go, just like keep moving on. But the two we have to worry about are rational functions and square root functions or even root functions. These are red. You got to pause and think about it because they do have restrictions. So rational functions, their restrictions are that the denominator cannot equal 0, right? We can't divide by 0. So how we find the restriction is we set the denominator equal to 0 and solve, and these are the x values that are excluded from the domain, okay? So like in this case, x could not equal positive 8 and negative 2. If we had set x minus 8 equal to 0, you get 8. X plus 2 equals 0 equals negative 2. These would not be included in the domain. So that means usually the domain is negative to positive infinity. In this case, we have to skip over negative 2 and then skip over positive 8. So we're going to go negative infinity to negative 8 and skip over negative 8. And this is what it looks like in interval notation when we skip over negative 8. Both of those open parentheses say don't include negative 8. And then we keep going until 2, where then we have to skip over 2, and then we continue to positive infinity. So right here is where we skip 8, skip negative 8, and then we skip 2. So when you have a rational function, whatever makes the denominator 0, we have to skip over those. We cannot include those in our domain. Square roots also have restrictions because we can't take the square root of a negative. So whatever expressions underneath the radical, in this case, has to be 0 or greater than 0, right? So it has to be set greater than or equal to 0. So in this case, x has to be greater than or equal to negative 7. Same thing for any even index. This has to be set greater than or equal to 0. So x has to be greater than or equal than negative 2. Okay, so our x values, we can't plug any x value that we want in here. Our domain is not negative to positive infinity. It's only our domain, the x values that can be included on this graph are x values that are greater than or equal to negative 7. So the way we write that is saying, well, the smallest number x can be is negative 7. We can include negative 7, and then we can be any number larger, right? X has to be greater than or equal to negative 7. So we write our domain like this. For x is greater than or equal to negative 2, you would write it like this, okay? So really, the two that you need to worry about are fractions and square roots, right? So when we look at these, we can take a look at number 5. Because this is an odd index, there is no restrictions. Our domain is negative to positive infinity. For number 7, since it's a square root, there is a restriction. This expression cannot be negative. So we say this expression has to be greater than or equal to 0. When we solve, we get that x has to be greater than or equal to negative 3. Visually, these are the numbers. X has to be greater than or equal to negative 3. So as far left as negative 3 and then to the right forever. Number 6, here's a rational expression. We have a denominator x squared minus 9. The denominator cannot be 0. So when we solve, we'll add 9, take the square root. We get that x can't be positive or negative 3. So if we were to graph this, we would say here's negative 3, here's positive 3. X has to skip over negative and positive 3. So we could be any number from negative infinity to negative 3, skip over negative 3. Any number in between negative 3, positive 3, and then 3 to positive infinity. So it would look like this. Negative infinity to negative 3, skip over negative 3. In between negative 3 and positive 3, skip over positive 3 to positive infinity. So this would be our final answer for the domain. And last one, what if we put both of the ones we have to worry about together? So notice we have a fraction and a square root. So when we think about this, the square root says we have to be greater than or equal to 0. When we're in the denominator, we can't equal 0. So if we put these two restrictions together, x has to just be greater than 0, not equal to. So we take the x plus 1, set it greater than 0. X has to be greater than -1. So our number line looks like this, but the difference is this is an open circle, so we use open parentheses. Okay, so that is domain and range, and when we do equations, we're just worrying about the domain. Copy that down, rewind if you need to, and I'll answer all questions in class. Have a great day, guys.